All right, ladies and gentlemen, we're looking at 3.3, which is proving lines are parallel. So this is the exact opposite of what we were talking about before. What we're going to do is we are going to use the corresponding angle theorem, but we're going to use the converse. And the converse is going to be able to tell us if the two lines are parallel, if we know that the corresponding angles are congruent. And we're going to use the alternate interior angle theorem, which is going to converse, which is going to tell us if those alternate interior angles are congruent, that the lines are parallel. And we're going to use alternate exterior angle theorem, converse theorem, which is going to tell us if the alternate exterior angles are congruent, that the lines are parallel. And we're going to use the consecutive interior angle converse. Two lines are cut by a transversal so that the consecutive interior angles are supplementary, then the lines are parallel. So we're going to look at this first proof. We're going to prove angle 1 is congruent to angle 2. We're given that, and we're going to prove that K is parallel to H. So first we're going to say angle 1 is congruent to angle 2, given. Then we're going to say that angle 2 is congruent to angle 3 by vertical angles. And then we're going to say angle 1 is congruent to angle 3 by transitive. Therefore, K is parallel to H by corresponding angle converse. Corresponding angle postulate converse, or converse postulate. Now we're going to look at part A. We're going to prove that A and B are parallel. Therefore, 55 has to equal x minus 8, and that is the alternate interior angle converse. So we're going to add 8 to both sides, and we're going to say 63 equals x. Part B is also the alternate interior angle converse. So 127 has to equal 5x plus 2. So we're going to subtract 2 from both sides and say 125 equals 5x. Divide both sides by 5, and x equals 25. All right, we're going to go ahead and look at this other proof on the back of our sheet. We are given that angle 1 and angle 2 are supplementary. And that P is parallel to Q. So our first is our given, angle 1 and angle 2 are supplementary. I'm going to just abbreviate that, and that's given. Then we're going to say the measure of angle 1 plus the measure of angle 2 equals 180. And this is just definition of supplementary angles. And then we're going to say the measure of angle 2 plus the measure of angle 3 equals 180 by the linear pair postulate, because they form a straight line. Then the measure of angle 1 has to be congruent to the measure of angle 3, measure of angle 3, by the congruent supplements theorem, which states if one angle is supplement to two others, then those two others must be congruent. Therefore, we've proven that P is parallel to Q by the alternate interior angle converse. Okay, now we're going to go and look at the bottom of this page, and we're going to be able to prove that some of these are parallel lines. These are corresponding angles, so to prove A is parallel to B, they must be equal to each other. We divide both sides by 8, and we get x equals 7. For part B here, we know these are alternate exterior angles, so they must be congruent. So we must divide both sides by 4 and get x equals 16. Then we're going to look at these last two. They're a little tricky. We know that alternate exterior angles would say these two angles are congruent. And we know that these two angles are supplementary. So 105 plus 4x plus 3 must equal 180. because if those two angles are equal, then that one must be supplementary to both of them. Therefore, we get 108 plus 4x equals 180. Then we're going to subtract 108 from both sides. And we get 4x equals 72. We divide both sides by 4, and we're going to get x equals 18. Now for this other one, we know that these two angles are congruent by alternate exterior angles, and then we know these two are supplementary by linear parapostulate, so those must be supplementary to each other. So what we're going to do is we're going to combine like terms. 103 and 7 is 110. 103 is 110 plus 14x equals 180. Then we subtract 110 from both sides. And we're going to get 14x equals 70. Divide both sides by 14. And we'll get x equals 5. So the real point of all of this stuff is just to remember, if you're trying to prove things are parallel, you're going to use the converse. If you already know they're parallel, you're going to use the regular one.